better when so like Jay, you were saying you wished you had prepared a little bit more, but I almost wonder if it's better when like you had a pretty good level of preparation where like both me as a watcher and the people who were in the recording seemed to be able to like have enough time to think and ask questions and discover stuff together, and it seemed like it worked out really, really great.
Yeah, it was awesome. A formal presentation isn't what we're here for, really.
Yeah.
That was a pretty well presented session. I mean, I don't know that more preparation would have helped, really helped it.
And another thing is we can use these sessions to polish up our presentations to make them ready for wider audiences.
Yeah, totally.
Yeah, I watched it also. I really like it. Yeah, really nice presentation.
Jay, did I see some commits going into that repo in the last week?
I think I might have like touched something up, but I was starting to look into seeing if I could port it to WebAssembly.
Oh, wow.
Yeah, because Isaac had mentioned how cool it would be to be able to show it visually. And I had mentioned the D3.js framework, which is for visualizing graphs in the browser. So it'd be cool if it were like a WASM library.
Yeah. Yeah, so you showed us previously that game of life that you wrote in Rust and compiled down to WASM, right?
Yeah, right. This one's a little more complicated. I've already run into like I think the boundary of like where WASM is currently being developed in the Rust compiler.
Oh, wow.
So yeah, we'll see.
We use D3 for some of the visualizations we do in the social ledger. So that'll be perfect when we get social ledger on our chain, right?
So what is D3? So I know Isaac had recommended GraphViz in the recording, which I had heard of and used a bunch too. What is D3? Is it like a similar thing, but web-based?
Yeah, it's not just for graphs. It's kind of like what do you call it? Like the Haskell type. It's not imperative programming, but the other
functional?
kind.
Object-oriented?
It's like when you define like what you want to be the case, and it builds
more declarative, right?
Sorry?
More declarative, you mean?
Yeah,
declarative
like or operational.
Logic programming? Is that what you're talking about?
It's like operational programming or denotational. Like
Denotational, okay.
Yeah. So you basically just like build, what you want the data structure to look like, and then D3 will kind of format it visually however it thinks is best.
Oh, cool.
Yeah, it works similar as React. You say your model, and that D3 will render your image in SVG or Canvas or something. Mm. I posted one link to some other library to represent graphs. Oh, they really support like a network analysis and similar things. But I was trying to visualize Casper, but I didn't find any template.
Sorry, I was on mute here. I just wanted to show you what we're doing with our portal. And the portal is part of our self-sovereign stack that we want to interface with the Archain wallet. But we use, and this is all browser-based. And we can, for example, show, the holonic charts of, these are the channels, and the darker ones are recently active. The white ones haven't been active in a long time. And click on a channel, and go into it. And this portal is a frame on all of our applications. And we have, basically, as we go into each of the applications, we have a ledger of that we use and a record on the social ledger of that, of the tools, whatever they are. Like we have tool like task management tools. We got calendars. We got well, we have different domains here.
So the very front page that you showed us was relevant to like D3 or something. Is this D3?
Yes.
D3 is what we use for visualizations. We do another visualization here, which is
Oh, cool.
where we show the connections of people. And the strength of the connection is the width of the line. So you see strongly connected here. We can see people here out in the middle of nowhere.
Oh,
Wait, so I've seen something really similar to this. That was all of the commits that happened to the Archain GitHub. Have you guys seen this? Do you know what I'm talking about? It was like a brief video. They like built this connection graph where they had like all of the projects and the different commits in each project, and then you could see like the branches being, you know, like created and then destroyed and like merged into other things. It was really cool.
Yeah, and with the GraphQL interface to GitHub, and free library, it's really easy to render these things.
Oh, that's awesome.
nice.
Is this only read only, or you can modify something with that visualization?
Are you talking about the GraphQL interface to GitHub?
No. I'm talking about this interface on this site.
Well, I mean, you know,
Is it?
It talks to the back ends with the API of Mattermost or GitHub or whatever. I mean, that's how you update things. And as I understand it, with the D3 framework, it will render in real time as events back that things have changed, whatever.
I see.
Nice. Well, does anybody have anything consensus they want to share or talk about today?
Not particularly consensus related what I have to talk about, but yeah.
What do you have on your mind?
I mean, I just have like tons of stuff in K if you guys are interested in hearing about it.
Yeah, sure.
Cool. I know I mentioned that last week I wanted to present this COM predicate that I have, and my computer just totally crashed during the Zoom session, and it seems to be working. I mean, that's what I'm on right this second. So it's currently working. So maybe I can present it to you guys if nobody else has consensus stuff.
I just have one thing, which is sort of a connection I made in my mind. I mean, my background is in research on collective intelligence, and part of the research we got was on leaders, and that if the group elected a leader, they would reach a consensus. Okay, and then when we had what we call the computer leader condition, where after collecting the sentiment of the individuals, the computer would generate a rank ordering of the alternatives based on the individual feelings. And then they would have a round of discussion, and then the computer would present another, the updated view of the group consensus. And I had what was called the fascist interface, which we never actually run except with students, which would say you disagree most with the group on this item, or on the rank ordering of these two items. Do you want to justify your position or go along with the group? And of course, everybody said, I'm going along with the group. and we got consensus in like 2 seconds. I mean, a whole hour scheduled for this thing, was settled in 5 minutes. So they never did a formal experiment with it because it wasn't clear that it was generating a good consensus or collective intelligence, which we didn't measure at the time. But for my computer leader case, but the feedback case that I described initially, computer leader condition, we found that groups that chose a leader and the groups that had this computer leader would reach consensus and exhibit a collective intelligence. In other words, they would solve a problem better than any individual before the interaction.
And how you choose a leader?
If we had the computer leader and the group selected a leader, a human leader, they didn't reach consensus and did not. And the group solution was worse than the best individual solution in the group.
What kinds of things were you trying to reach consensus on in these experiments?
There was a rank ordering, and there were several problems we used. Like one was how valuable would this list of items be if you were in some survival situation?
Oh, yeah. Like what item would you most like to have and which one is kind of useless, and rank them in between?
Right. And
Yeah.
then, of course, I mean, this was a classic, these were classic problems where they had different groups of experts evaluate the items so that we could measure the quality of solution.
Yeah.
So you first you said that you choose a leader. Is this also part of the consensus, or?
Well, I mean, it certainly enabled consensus. Okay, and I thought of this when I was thinking about the consensus protocols that use leader, where they choose a leader. So it was just like our experiments, so to speak.
I mean, what is the consensus to select a leader? I mean,
yeah,
they must have some kind of consensus.
yeah, that was informal. In other words, they would just have a discussion, and people would would discuss it, and then they would vote on it. So it was voting.
Oh, I see.
Yeah, and I just felt that I've always felt that there's a human consensus and the machine consensus were deeply rooted with each other, and ultimately the same thing.
Yeah, and who care about computer consensus, right?
Right.
I mean, why we should care about computer consensus?
Well, we want to create an incorruptible ledger for one thing, and have with verified computation, right?
Yeah, but we are interested in final result, and this is like some intermediate computation.
Right.
In that sense, I think that we are not interested.
Right. Well, basically, it's so that we can't be controlled. That the intermediary is not the government. It's not the mafia or the whatever. It's the blockchain for our interaction, which is trustworthy, hopefully. And it's, in one sense, it's trustless though, and you know, the challenge that I think we're facing, and certainly one that I'm facing, is enabling trust using the blockchain.
So Thomas Love, you recently posted some videos that were like a kind of a long interview with Leslie Lamport.
Oh,
and
yeah.
the notes you took on him. I haven't watched the second one yet, but I watched the first one. And
they're real long.
What?
They're really long.
It's really long. I started watching it thinking it was going to be like a half-hour lecture, and then I got to the point where I was like, oh, I've got this is almost done, and I was like 45 minutes out of 3 hours into it.
Wait, these are the ones about TLA, right?
Yeah, but not only about TLA.
Not only about TLA. Okay.
About his whole career almost.
Oh, wow, cool.
One of the things that he mentioned in that first video was that on big airliners, there's all these sensors, you know, roll, pitch, yaw, airspeed, altitude, fuel, just a million of them, and like autopilots have to make a bunch of decisions based on all these sensors, and at any given point, one of them or a few of them might fail, and like obviously that's not good. Fix it before your next flight, but it's also not the end of the world, and human pilots have dealt with that successfully for a long time. And he was explaining that like the way that they got that working in autopilot was to actually run a consensus game where the validators are like these sensors who are mutually distrustful of each other, and failed sensors that, you know, like incorrectly report the altitude are like, you know, Byzantine players, and as long as you're less than a third, then your autopilot should still be able to fly correctly and stuff. So that was when you briefly said like, do we really care about machine consensus? That was an example of when I thought
the basic fault tolerance, you know, where, you know, you have 3 sensors and if 2 of them agree, you go with that. Okay.
Yeah.
Is, you know, simple error correcting code, right?
Yeah. Yeah. I think in this example, it wasn't necessarily even like whether they agree with each other directly. You know, like it's one thing if you have like 2 or 3 airspeed indicators, and then you can, you know, say like, well, these ones mostly agree, but it's like, okay, well, the airspeed says one thing, and the pitch says another thing, and the roll says another thing, and like those are not, those can't be consistent. But like which one of them is wrong, then we have to play that kind of game.
Yeah, I was just giving the simplest case.
Yeah, totally. Yeah.
Yeah, I was thinking more in a sense of at the end we want to say you know, we don't want to for this plane to crash. Like this is our consensus, and you know, do whatever you need to do, but you know, I'm thinking that maybe machine will get their own way of, you know, looking at consensus. You know, something that for us is not acceptable, right? But for the perspective of machine, this is completely logical. You know, we make consensus, and you know, and we all die. You know?
Yeah.
This kind of consensus is not very good. Yeah. Well, I mean, consider, you know, a machine having to decide between, let's say, a plane crashing and
this is going to be
1,000 people dying from the plague or something. Okay. Humans, worry much more about things that are smaller problems than then the larger issues. I mean, if you look at the causes of accidental death, okay, in terms of how many people die, there's a couple things that people are really concerned about, like guns, for example. Well, 60% of inmates used illegal guns in their crimes. Okay, so if we tightened gun laws, this is a boon for the mafias and the illegal. Anybody can get an illegal gun today, just like they can get illegal drugs, or like they could get illegal alcohol in the prohibition. But the criminals don't want it to be legal. They make huge fortunes because the market is illegal. So of course they're going to promote and socially engineer people to want to cut that back on legal guns. And my point was,
you were talking about machine consensus and the airplane crash versus the plague.
Yeah, I got back on that other thing. My mind was blown. But the point is that humans are risk takers for one thing. They'll they don't care about the odds so much as, well, if there's a chance, I'm going to take it. Okay, there's differences in the way humans, there's illogical ways that humans behave that is important to our survival. Okay, and the computer being logical was the point, maybe something that impacts, that puts it at odds with, what humans make. I mean, it may be perfectly logical. We want to solve the problems. Give everybody a gun. Okay, the computer might come up with that answer.
Or maybe we can.
Nobody did any crime because they know the other guy has a gun. Yeah. I think that computers will be the servant of man and will do illogical things at the bidding of man. We don't have to worry about the computers having a mind of their own. We have to worry about the minds that control the computer.
But for me, the ultimate example was one episode in Star Trek that, they came to this one planet which is in war with another planet, and they had Kirk and Spock was there, and in that moment, like missiles are hitting this planet, and they are confused. These guys on this planet, they are saying they have like very much of the casualties, but they cannot detect. Like Enterprise doesn't detect any missiles, and they have simulated war, and they have simulated how many deaths they will have, and so they killed that much of the people. And so I really want to say that maybe we put too much power to the machines, right? I don't think that a lot of smarter machines will, for us, will done too much, right?
I think we'll have a new golden age where everyone is has the machines as their slave. I mean, all great civilizations have been built on the backs of slaves and serfs, and today, the wage slaves that we are engineered to become. But machines have a promise of enabling us all. And that's why we're here, right?
Yeah, but we can see it, but this is not true for everybody, right? You know, if you have some very nice robot that looks very similar to human, I don't think that this kind of robot will be slave to everyone, which is completely fine. It's a machine, right? But
No,
I think that we will have slaves to this robot.
our chain is algorithmically constrained to follow my rules. Okay, it's a world computer under my control, and as we share, we get power. The mass becomes more powerful than the powers that be. You know, and our challenge now is to exceed the Dunbar number, which is only 150 people. After that point, decentralized cultures break down historically, and unless they're face to face. And it's hard to have a community face to face, larger than that.
But do you think that problem is also the difference between different groups and their understanding of this technology and everything, you know? Because some group of people can have better understanding and can use it to solve their problems.
Yeah, they've been using it against us for decades. You know, there's no question about that. But I don't think it's a matter of that. It's a matter of you know, social knowledge, really. And you know, we can think that how people think today is going to limit the future, and certainly that happens. But what happens in the future is generally surprising. It's not what we expected. You know, all of a sudden, the latest craze could be anything. It just takes a catalyst. Okay, if you have that catalyst, it explodes. So, and that changes everything, like happened in the 60s. And then the reaction to the 60s that followed. And
yeah. And it's usually like really unrelated stuff too. Like the whole AI movement, you know, of this decade. It wasn't from any like development in some new algorithm. The algorithms have existed for 50 years. The biggest development was that graphics cards for games got better, and that enabled it. Like who knows, you know, what's going to cause the next big thing.
That's an interesting tidbit. So you're saying like graphics cards started to get bigger and beefier because people really liked games, and that happened to allow like more complex AI things to be calculated?
Exactly, because you know graphics cards are super parallel processors to, you know, process the screen, and then all we really needed in AI was the same algorithm, just a lot bigger and a lot more layers.
Yeah.
So.
well, gaming got it started. I mean, let's face it, gaming's pretty lucrative. But what really brought it to fruition was Bitcoin.
Gaming? I think Bitcoin brought gaming to fruition?
No, brought GPUs.
Oh.
These processors that enable artificial intelligence.
I think Bitcoin's brought ASICs to a new level too, because Bitcoin quickly outgrew the GPU. People developed, you know, their own hardware to process exactly the Bitcoin algorithm and to run through a whole bunch of different random hashes with the least amount of power.
That's true. Yeah, they're not general purpose anymore.
Yeah. Now they call them GPUs,
Yeah.
general purpose GPU.
Sounds twice as awesome.
But what we're gonna, the process calculus machines we're gonna make are going to be specialized as well.
They're distributed.
Big quantum.
Tomislav, I heard that you wrote some kind of HTTP server that runs on Erlang. Is that true?
Oh, I added a system contract that calls HTTP directly.
No, this is just so awesome. It's like, it's an external channel to the art chain, so that you can write to an external channel, HTTP, to get a web page or to execute some API, and you can read from it to be a web server. Okay, you just read the URL and boom, you're a web server.
So, but it serves pages.
So yeah, I didn't make a web server. I just made a HTTP request. But I wanted to communicate back to our node, so I have another Node.js HTTP server, and between them I created a long pooling connection, so I can call back our node.
Yeah, it's it's whatever you write to the channel is what's going to be read by the HTTP request.
Gotcha.
So it is a web server, but what you serve.
It's like a web client more, right? It makes the requests.
No, you can. It does both. It does both.
Well, Jim, I didn't implement it directly in Erlang. I didn't implement a web server to accept requests. So in that sense, it's just a client. But I fixed that with a long pooling connection to Node.js server. So it's
okay. I was
it looks like
right. So you provided a way that gives the effect of reading from an external channel.
Exactly.
And writing to an external channel.
Yeah. Yeah, but it can be extended to accept connections and. Yeah. Well, I would like to talk about this in some other session in the future. I will create a more robust example with HTTP server. Maybe connecting to other node and reading data.
Yeah, I actually didn't even think about how you could connect it back into an R node. I was actually just thinking about how the process calculus would work as a HTTP server or requester.
Isn't that what
was most interesting to me too? Just like a Erlang interpreter that has enough abilities to communicate with the external world that we can write, cool things like web servers or whatever else straight in Erlang.
Right.
I thought that was your gRPC server, not the HTTP, Thomas, isn't it? You were doing a gRPC connection to other art chains.
Oh, between our chains, you mean?
Yeah.
So, I'm thinking more in a more general way. What primitives do you have in your Erlang? What can you use? So this HTTP process is pretty high level, right? Because you're using existing library for all the HTTP parsing and whatnot. But I think we can have gradually we can enable all of these primitives to be a more low level. So maybe you will just have access to streaming by stream, and all of these protocols should be written directly in Roland. So from this point of view,
your content type could be gRPC, protobufs. No reason. Yeah, I can see how that's generalized. And so all you need really is the HTTP or the HTTPS and the WSS, the WebSocket, and you've got your bases covered.
Yeah, if for start, right? Now, in the beginning, you can directly use these libraries from Java, but later, why not write all of this logic in Roland? Parsing the byte stream and everything.
Now, it can be transparent to the application, whether it's handled natively or through a proxy, right? You can write applications that use these connections.
Yeah, but in a sense, we have a completely closed system, which is just a rolling, right? And this is part of the blockchain. This can be written to blockchain, but we can easily see we can attach special functionality on some reduction. This is how I look at this, for example, HTTP request. If you can say I can respond to change on this unforgeable name and connect it to something off chain, this is how I see this HTTP request. So something is happening inside the blockchain, but on some specific transition, you make HTTP request to outside, or some byte stream. You send some byte stream on the outside, and you will get some event later that will transform this blockchain again. So at the end, this communication on the edge, on what is inside the blockchain, what is not. This is like a critical point.
And consensus among blockchains or whatever.
Yeah, this is the same thing. This is also like external input or external events. So I'm thinking that if we know what can we access inside the rolling, we will get good approximation. What can we do, and what because yeah, it would be nice to have very low level primitives now in rolling to start building maybe low level stuff like parsing or something.
I guess Isaac got tired of waiting to do his thing. He left.
Oh.
Tomislav, did you say parsing? Like doing parsing in rolling?
Yeah.
Yeah, that's the vision. I mean, not specifically parsing, but yeah, being able to do like all that arbitrary stuff. But I will say parsing in particular is a little bit inception-y for me, because I learned how to do parsing specifically to write a Rolang interpreter. So like now doing parsing inside a Rolang, it's like, whoa, that kind of blows my mind.
But you remember in Haskell, the main method for parsing, the main function, is just to say, give me one more character.
Yeah, right.
So maybe now we can have this as a primitive in Roland to just get another character, and somehow we can combine this parsing in more complicated. You collect 3 characters and you say, I understand this is like a new operator with 3 characters, something like that.
Yeah.
Seems like there must be metacalc somewhere.
Sorry, must be.
It seems like there must be a metacalc somewhere, a metacalculus, which I guess is like sort of what K-framework is, I guess.
I'm not sure that I understand you. You're saying meta calculus, right?
Like a meta interpreter.
Yeah, well, a language to do that. I mean, there is language that defines calculus. It's mathematics, but it's sort of
like a global calculus.
right, global calculus. And I guess you have things like you have process calculus like pi, and you have lambda calculus, and in a sense they're metacalculus because you can define any other calculus and any complete calculus. But it seems like you could have a common root, which is sort of, I guess, what K-framework is trying to do, so that you can generate any kind of calculus you can imagine.
Yeah, I mean,
but one important.
Oh yeah, no, I was just going to say the claim is that you can define any programming language that exists or that you want to create in K-framework, and even including K-framework itself.
Yeah, Isaac, I just remembered something that I heard. I think this was before you were even working seriously on K-framework, but I remember a claim that like if you have two languages that are like fully defined in K, and you've written a program in one of those languages, like that it can transpile and generate an equivalent program in the other language. Is that right, or does that sound like even possible?
I'm sure it's possible. I'm just wondering if I couldn't just make a meta language that like imports both of those languages, and then you can just create maybe something in the meta language. I'm not really sure how that would work, but I'm sure it can be done.
Yeah, that's pretty interesting.
Yeah.
That would be really useful.
Well, but some languages are just more expressive than others, right? So like if I express something in a more expressive language, like it seems like some subset of things shouldn't be able to be transpiled down to a less expressive language.
Yeah.
Does K-framework like set any restrictions on the language you define?
Boy. I mean, there are definitely restrictions. I mean, like, so, obviously it has to have like sound typing and that sort of stuff. You define the parser, and it creates the interpreter from the parser that you're defining, along with your rewrite rules that you're telling it are associated with each of the syntax constructs. So I guess maybe as few restrictions as they can get away with is how many they make you said.
It goes back to language theory and string languages. Okay, where that's sort of the root of all languages. If it's a universal string language, it can be the root of all other languages, and I guess that would be the place to go back to.
What's a string language?
And I was a master of string languages back in the 70s. In fact, I did my my senior project in college.
What's a string language?
Is it like
It's like a macro
automata? No.
What was that?
You said like a natural language?
Oh.
Well, okay, if you go back to language theory, you know, yeah, you start with a sequence of characters, right? And then you can have rules of transformation of those characters, right? And so string languages tended to be like macro languages, where you put in certain patterns that would get replaced by other patterns.
So that, okay, that sounds pretty interesting. So you're saying
your program kept evolving into another program that, you know, until it came to some stable state or produced some results.
Like a grammar or something.
yeah. So Jim, am I understanding correctly that like the program is basically like a string of symbols, and the symbols are like you have some alphabet of symbols. So maybe my alphabet is like
the languages I was working with, they were just characters.
Yeah, characters. Yeah, exactly. Okay. So if I do like a program is like AAB, and then there's these reduction rules, like separately, there's a table of reduction rules that says like whenever you have two A's in a row, you rewrite it to an A followed by a B or something like that. Is that what you're thinking of, or not really?
Yeah, that's the top level.
Yeah.
And then the actual, where you actually do useful programs is more like a macro language.
Oh.
Okay, you say, well, the percent does this, or whatever, so that, yeah, you've got rules at the top that describe your macro language, so to speak.
Yeah.
And it's what gets replaced by that sequence of characters. Yeah, I did an inference language in track. I mean, an inference engine in track for my senior project. So you just gave it statements like all cows eat grass, or syllogisms, and it would solve syllogisms or go away. If it was too complex, it just wouldn't give any answer.
Yeah.
But it was a lot of fun, and I think I became a master of regular expressions because of my experience with string languages.
Yeah, I noticed that you really like regular expressions.
And I forget most of, I couldn't write an algorithm in a regular expression today. I'd have to go back and study it. It's, so many languages and things I learned that are long gone.
I've just seen problems where my attitude would have been like, there's no way we could possibly do this with a regular expression. It's way too complicated. And the next thing I know, you've got a three lines worth of regular expression that works, like parsing the output of our node, for example.
And then I do a Google and I find a regular expression this long that does the same thing. I wrote a program in track that, a program that output itself. What do we call that?
Quine. Isaac and I were working on those a couple months ago.
It took me 63 characters.
Did you see mine in Rolang?
No.
I don't remember where it is, but
was it longer than 63 characters?
Probably.
I wouldn't call you a master of string languages. But it probably could be reduced to 63 characters. Okay, and to some extent, my playing with macrolang is so that we can, in 63 characters, express the code that Joshi developed there.
Yeah. Well, should we switch over to computational calculi officially and let Isaac show us his com predicate?
I think it's time, so I'll restart the recording again.
Fine with that.
Or just let it go.
Yeah, I'll share my screen.
Any suggestions? Should I restart the recording or just continue?
Restart.
Yeah.